Now that we're able to solve exponential equations, I want to look at an application problem. Let's find the time required to double an investment at 6% interest if the interest is compounded semi-annually, and then if the interest is compounded monthly. Remember that for compound interest, we have A equals P times 1 plus R over N to the nt power. In this situation, we want our investment to double, so A is going to be equal to twice the principal, and then we can divide both sides by P to actually get rid of the principal. That gives us 2 equals 1 plus R over N to the nt power. Now I want to look at these two situations separately. So first we'll look at what happens when the interest is compounded semi-annually. Here we have 2 equals 1 plus the rate, which is 0.06, divided by 2, because it's compounded twice per year, to the 2t power. Now 0.06 divided by 2 is 0.03, and 1 plus 0.03 is 1.03. So this becomes 2 equals 1.03 to the 2t power. And now we have an exponential equation that we can solve. Let's solve it by taking the natural logarithm of both sides. This gives us ln of 2 equals ln of 1.03 to the 2t power. We know that we can bring the exponent out of the logarithm as a coefficient. So this gives us ln of 2 equals 2t times ln of 1.03. And to get t alone, we need to divide by both 2 and ln of 1.03. So when we do this, this leaves t alone on the right, and on the left we've got ln of 2 over 2 times ln of 1.03. And using a calculator, we can get an approximation. This is approximately equal to 11.72 years. Let's see what happens if it's compounded monthly, if this will make much of a difference. Here we have more or less the same equation. The only difference is that the value of n is 12 instead of 2. So that denominator is going to be 12, and we're going to have 12t in the exponent. Now, when we take 0.06 divided by 12, we get 0.005. And so when we add 1 to that, we're going to have 1.005 to the 12t power. Now again, we're going to take the natural log of both sides. That gives us ln of 2 equals ln of 1.005 to the 12t power. And then just like before, we're going to take this exponent and bring it outside as a coefficient. So ln of 2 equals 12t times ln of 1.005. And then to get this t alone, we need to divide by 12 and by ln of 1.005. So we end up with ln of 2 over 12 times ln of 1.005. This is our value of t, and we can use a calculator to see that this is approximately 11.58 years. So it would be a little bit faster if we're compounding monthly instead of semi-annually, but it doesn't really make that big of a difference in the long run in this situation.